Our topic is about skin cancer detection using transfer learning and ensemble modeling. Now, starting with the abstract, this article discusses about transfer learning and ensemble learning trained model for detection of skin cancer, which consists of mobile net, inception, and exception learning on pre-trained models based on image scans of the infected part of the body, thereby helping in an early detection of skin cancer. Now, coming on to the introduction part, as we all know that the skin cancer is an alarming disease for mankind, the necessity of an early diagnosis of skin cancer became urgent as it would prevent the high treatment costs and the death rates which can be avoided. The most known causes of skin cancer are exposure to UV light and radiation. They can damage the skin's DNA, which leads to skin cancer. And the techniques which we are going to use for detection of skin cancer are transfer learning and ensemble learning. Now, transfer learning is a research related problem in machine learning, which focuses on the storage of knowledge gained while solving a problem and applying it to a different but related problem and help improve the solution for the problem. Now, the ensemble learning is a process by which multiple models, which can be newly built or pre-trained models such as classifiers or experts, can be strategically generated and combined to help solve a particular computational intelligence problem and find a better solution for it. Now, ensemble learning is majorly used to improve the classification, prediction, or function approximation of the model which we have developed. The goal of this application is for the public and can be used by anyone to help them follow medical precautions. Now, coming on to the background part, skin cancer is an alarming disease for mankind. The necessity of an early diagnosis of skin cancer has become more and more critical, and also it has become very high treatment costs and death rate, which can be fatal for the person suffering from the disease. The cancer cells are detected manually, and it takes a huge amount of time to cure in most of the cases. This application is intended to help people in the pandemic time so that they do not have to risk their lives on getting the laboratory tests physically. Now, melanoma specifically is responsible for the deaths of 75% of skin cancer patients. Despite being the least common skin cancer among all, the American Cancer Society estimates that over 100,000 new melanoma cases will be diagnosed in 2020, and almost 7,000 people will die from the disease due to lag in early diagnosis or several other factors. As with other cancers, early and accurate detection, potentially aided by the improved concepts of data science, can make the treatment more effective. Now, it is possible for the dermatologist who could enhance the diagnostic accuracy if detection algorithms consider contextual images with the same patients to predict which images are likely to be positive for melanoma. If classifiers would be more accurate, could better help better help dermatologists. It uses this model uses images and predicts the likely of melanoma. Using patient level contextual information may help for the development of image analysis tools for analyzing the image taken as the input data. Now, melanoma is a deadly disease, but if it is caught at an early stage, then most melanomas can be cured with a minor surgery. Image analysis tools that automate the disease of melanoma will improve the dermatologist's diagnostic accuracy with the help of improved algorithms and calculation mechanisms, and help the dermatologist take better decisions. Better detection of melanoma can positively impact millions of people. As pigmental lesions occurring on the surface of skin, melanoma is amenable to early detection by expert visual inspection, which is possible with the help of specifically designed algorithms in machine learning and with higher power computing. It is also amenable to automate detection with image analysis given the widespread availability of high resolution cameras algorithms that can improve our ability to screen and detect troublesome lesions can be of great value. As a result, many centers have begun their own research efforts on automated analysis. However, a centralized, coordinated, and comparative effort across the institutions has yet to be implemented. Now, dermoscopic is an imaging technique that eliminates the surface reflection of skin. By removing surface reflections, visualization of deeper levels of skin is enhanced. Prior research has shown that when used by expert dermatologists, demoscopy provides improved diagnostic accuracy in comparison to standard photography. As inexpensive consumer demographic attachments for smartphones are beginning to reach the market, the opportunity for automated dermoscopic assessment algorithms to positively influence patient care increases. Now, deep learning models have been built to classify and identify the binary diagnostic group of melanocytic images obtained through dermoscopic based on models disease detection through dermal cells images that have been investigated and classified on dermal cells investigations dermal cell images have been performed.
Hello everyone, my name is Ashish and I'll be continuing with the general architecture. So the overall model has been divided like into pretty much 10 stages and we'll come to those one by one. But before that I would like to discuss some of the advantages of the learning model which we have created. So the first one is that we've used tensor. um, it's the reason behind using them is they are faster actually, and one more reason is that we have a lot of data, like, and it's image data. We know that it can take time to process the image data, so we simply cannot have a model which might spend huge amount of time, like say ages, to train on the data which we have provided. So we need it to train quickly. So that's the reason. So we've used it to save a little time in training, because it when we have a huge data set, or especially images, it's going to take time, because it has to convert the image to its readable form, which is numbers. Like, it's an image for us, but a computer will be able to understand it in numbers. So at the end of the day, it's just numbers for it. So the next advantage is that we're using some of the well-known models which been created by like the tech giants Google. Like, so the thing is that these models have been trained really well on general data. So we can train them specifically for our application, and we can use them. And the advantage which we get when we have these being trained on general objects is, like, probably I can say, like, object detection in the image. For example, like the skin cancer cells, right? So it's there on the skin, and if it's like suppose here, and it can easily detect this part, like, because it's gonna stand out, it's gonna have different features compared to the rest of the skin or the skin around it. So that's one advantage, I think I can say that. Now this is like transfer learning, so they're pre-trained. So uh, the thing is, they're really well trained, and we don't have to overtrain them. So we really need to take care about the amount of training which we have to do. So this is one advantage, because these here's the advantage now. Like, because these have been trained before, so we don't really need to train them too much. Like, we don't need to train them from the scratch. We just have kind of some checkpoints, and we can use them, and we can continue their training from that. So that reduces the amount of training time, and it can also reduce the number of epochs which we might have to use for this. So that's a plus point. So that's an advantage when it comes to the amount of time which our model takes overall, because um, we can judge our model based on the metrics which we have, or the evaluation criteria which we have. So the faster we can train our model, the faster we can conclude whether the model which we have created is actually working properly or not. And this can be done only by seeing the result from the evaluation which we can get after training only. So this is one advantage. Now another thing is, this is an ensemble of those renowned models. So we have taken several of those and created a deeper architecture. So the number of layers have increased, like an average architecture for all of them, all the algorithms, the models which we have used. So the deeper net, it's an advantage. It's better when it comes to analysis. It can help us increase the chances of finding out whether the person is suffering from cancer or not. Now, another advantage of the model which we have created is that we've kept in mind about the software developers. For example, our intention is to be able to provide this model to the general public who can use them, and there may be people who may not be able to pay for the test, so they, like, just in case if you just want to make sure at home, you can do that, like. And another advantage is that it can help at the hospitals uh, by the test results. Like, the test results take time, right? Those are the proper results which you can get, but they take a lot of time. So the medication should not be delayed, so the hospitals can use this. They can take like a clear image of the area which they think is the one suffering from skin cancer. They can upload the images, and the model will be able to predict whether the person is actually suffering from skin cancer or not. So that's one thing. Another thing is that we have tried to create the model very simple so that it can be easily plugged into software. Like, software developers can use this model, kind of try to plug it in, and create a software which can be used easily. Like, that's these are the advantages. Now I'll come to the main part, which is the architecture, the general architecture. So these are the stages which we have, and we'll be going through each of these one by one. So first of all, coming up to the pre-processing stage, all of us know, like, we need to process the data before we really, like, start using it, because um, we need, the computer cannot just, as I said before, the computer cannot see, doesn't see the image as an image. It sees it as a number, as a set of numbers. So we really need to convert this image into numbers so that the computer can understand them, it can work on them, it can process them, it can learn from them. So that's one thing. So we just used Google Drive in this. We uploaded a data set, connected the Google Drive to our model, so there's like an easy link. Another thing which we did was, there's like a set of images. Okay, so we can put those images together in, like, let's say, a list. Okay, uh, and there's another thing, like, the images could be scattered. It's possible, like, sometimes you may you might want to keep some specific results in some order, in some organized manner. So for this, what we have actually done is, like, we have tried to attach the path of the image with the file, so that file name, so that the complete path can be seen, and the image can easily be traced in Google Drive, because if it's like present anywhere in your drive, it should be accessible. So even if you have some image stored outside a folder, it can be accessed, provided that you are able to add the complete address of that image. So it's just like a list, so you can just keep adding images to it. And, like, the another advantage which I would like to add here is that it gives us the advantage to combine data sets if we want to. So for example, we have one data set, we have done training on that. Suppose I just want to bring in another data set for myself, and, like, it's up to me whether I want to train first on this data set and then again start my training on this one, or and, like, compare the results on both. That can be done. Or if I want, I can just I might even wish to join these two data sets together and train on them. But the thing is, I'll have to move so many images from one place to the another other place. So instead of that, what I can just do is I can take the complete path of these images. I can take the complete path of these images, just add them to a single list, and that's it. I'll be able to access them images all together. That's one thing. Then next part which I would like to get to is that this doesn't really because the images can be added easily, so it doesn't really interrupt the model. The model can continuously train it because it will be able to take all the images at once. Now, after this, the images are loaded into the model, like one by one, converted into tensors for faster processing. Then, the tensors are stored at a separate location. So, once we have created the tensor, we don't really need to create them again and again. So, we can just use them if we want. Like they can be used for further training as well, or if we want to, if we have different data sets, we can have tensors in different forms and we can just use them simply. So that's another advantage in this case. So this saves a lot of time again. Like we really kept this in mind, that the training can be done quickly in some ways. Like we've tried to just cut the time and bits and pieces, like here and there wherever like possible. So that's one thing. Now, next up, I'll be coming to training the model. So, as said before, this is like an ensemble of several renowned learning models which we have, which are MobileNet, the Inception V3, and the Exception architecture. So these are the pre-trained models. They are loaded into like these are pre-trained architectures. They are loaded into the model. Like we can load them however we want. We have created them as a function. Just like we can call them anywhere we want. Actually called them multiple times, so it makes it a little easier to access them. So they have certain checkpoints, then we continue the training from that for certain number of epochs, and then we can create our checkpoint, and if we want we can further continue our training from those checkpoints. We just fit the models for the specific amount of data which we have. Now since these are renowned architectures, they are really well trained, we haven't really had to train them too much. Like the number of epochs were actually very less, and we kept the number of epochs, keeping in mind we don't want to overtrain the model. We know that overtraining a model will not result in better accuracy or better prediction, because it's just like the model has really crammed on the results, and like we don't really want that. We want it to learn. Like it's you can actually predict better when you understood. Even as a human, if we see, like we have tried to mimic the human brain, so even as a human you can really predict better, or you can really tell something better when you've really understood things properly, rather than when you've just like crammed the things. It's just like it's not really that useful, right? So that's the thing. So the number of epochs are really important in this case. So next up we come to the prediction. So the prediction can be done in several, like we've created used the predict function for this one. Like initially we just took predictions on a few images just to see like the model is working or it's like causing if there's some error or something. So this really helped us. Then we predicted on the complete set of images which we have, and the ensemble model, like it came up with some little better predictions. So that's the uh, advantage of the model which we have created. And also because we have kept the app software part in mind, so it will be easy to access the predict function as well. So it can be easily plugged in with a software which can be used easily by like any general user. Like So that's one thing, and that's it. And now I would like my friend to continue from here. Thank you.
I'll be explaining about evaluating the models together and individually on validation data and testing data. Firstly, for the evaluation of models on the validation data, we have used the ROC curve, or in other terms, it is called as receiving operating characteristic curve. A ROC curve is constructed by plotting the true positive rate against the false positive rate. The true positive rate is called, or in other terms, it is the proportion of observations that were correctly predicted to be positive out of all positive observations. Similarly to true positive, the false positive rate is the proportion of observations that were predicted incorrectly to be positive out of all negative observations. If the plot obtained in ROC curve is close to the true positive rate, it indicates it has a good performance and accuracy. Suppose if the curve comes close to the 45 degrees, or it is near to the diagonal, it means it has less accurate. In this, we had computed the test set of predictions, and then the model has been evaluated based on the ROC curve. The values for the ROC curve has been obtained using the confusion matrix, and then we plotted the ROC curve from the values obtained from the confusion matrix to obtain the graph, and then check it for the best possible values, which can be used for predictions. Further, we also calculated the precision, accuracy, recall, specificity, and etc. others. And then to get the best results, we can also perform hyperparameter tuning with different parameters to get the best results. And we compared the test results of the pre-trained architecture and noted that we had a uh, the loss has been reduced, and if we train furthermore, means like if the number of epochs has been increased, it may overfit the data, and it might give wrong predictions when it is tested on unseen data or new data which it has never seen. And nextly, evaluating the models together on validation data with ensemble models. In this, we declare the input shape of the images depending on of its grayscale or RGB. Like if it is grayscale 1 or if it is RGB the 3. The ensemble model will be defined by appending all the models, and the images pass through all the models one by one, and their weights will also be combined. For evaluating the model, we had computed the test set of predictions of the model, and based on the ROC curve where the values of will be obtained using the confusion matrix. And after seeing the results that we have obtained, means the obtained results for the ensemble model seem to be better when trained on each architecture individually. Now, and next, evaluating the models individually on testing data. For the evaluation of models on testing data, we have used the ROC curve and similarly performed like the validation data with the values of the confusion matrix. Mm, And when compared the test results for the pre-trained architecture, we noted that the loss has reduced, and furthermore, if we train with the furthermore epochs, it might overfit the data. We found that the results obtained on the testing data are similar to the results obtained on the validation data. It means we have a good accuracy. And next, evaluating the models together on testing data. Similar to the evaluation of data on models together on validation data, we first pass the input shape 1 or 3, like 1 means the grayscale or 3 means the RGB. And similarly, we append the models for getting the ensemble model, and we'll be evaluating it using the ROC curve from the values obtained from the confusion matrix to get the best results. And we found that the results obtained for the ensemble model are better than each architecture individually. As we can see that number of true positive has been increased in the figure, and there are no false positives. And coming to the localizations, we can also use localization. I- In localization, we define a activation map with which we can display the results obtained on a particular image and plot the ROC curve. And further, the experimental results and the compared study will be carried out by my friend.
Starting with the data selection, the goal of the dataset selected is to develop the image analysis tools that will enable the automated diagnosis of melanoma from the dermoscopic images. The image analysis of skin lesions consists of three parts, namely the lesion segmentation, the detection and localization of visual dermoscopic features or patterns, and disease classification. Now, coming on to a comparative study, the comparative analysis of various skin lesion models is presented in the given table, and from which we infer that the ensemble models provide a better accuracy than compared with CNN models. As we can see here, that the evaluation of ensemble model on validation data has the highest true positive value, as the same on the testing data of ensemble model has a highest true positive value of 483. Now, coming to the final part, the conclusion. From this study, it is clear that skin cancer is an alarming disease. An early diagnosis is crucial in today's world as it leads to decrease in deaths due to skin cancer. And the appropriate system for early detection is encourageable, and the discussed ensemble learning plays a vital role in detection of skin cancerous cells with highest accuracy when compared to other models. Thank you.